When a solder joint is done correctly, the copper wire will snap before the joint itself ever gives way. To get that kind of secure bond, you only need 4 things: a 40 to 60 watt iron, rosin core solder, a brass wire tip cleaner, and some practice scrap wire. Before you plug anything in, you need a workspace with excellent ventilation. Lead-based solder is easier to learn with, but the fumes are a health hazard. An air purifier or a fan pulling air away from your face is mandatory. Securing the proper tools and clearing a safe environment is your baseline. If you cut corners on the setup, you guarantee a weak bond later. Step 1 is getting the iron up to temperature. You are aiming for roughly 350 degrees Celsius, or 662 degrees Fahrenheit. Turn it on and give it a few minutes to fully heat up. Once it's hot, you have to clean the tip. Plunge it directly into your brass wire cleaner a few times, or wipe both sides firmly against a damp sponge to remove any old residue. Never scrape the tip with sandpaper or a knife to get it clean. Doing that will strip off the tip's protective outer layer, ruining the iron's ability to hold heat. Instead, immediately apply a small amount of fresh solder directly onto that clean tip. This process is called tinning. This diagram shows why tinning is so critical. The liquid metal coats the tip, increasing the surface area and creating a highly efficient bridge for heat energy to transfer from the iron into your workpiece. That same liquid layer also acts as a chemical shield. It physically blocks oxygen molecules from reacting with the exposed hot core of the iron, preventing rapid oxidation. A properly tinned tip is what actually allows heat to flow into your wire without destroying the tool itself. Now let's prep the wire. Strip the ends and wipe the exposed copper with a little rubbing alcohol. This removes invisible finger oils that block solder from adhering. Next, tightly twist those 2 exposed ends together. You want a strong mechanical connection securely in place before you ever apply heat. Success depends on one specific sequence. The iron heats the copper wire, and that copper wire is what actually melts the solder. Looking at this diagram, you can see the exact positioning required. The iron is placed underneath the middle of the exposed copper. Notice how it stays safely away from the plastic insulation to prevent melting it. As the copper heats up, you introduce your solder wire from the top, directly opposite your heat source. The heat radiates upward, melting the solder. You will see a rapid wicking action as the liquid metal melts and smoothly flows into the microscopic crevices between the twisted copper strands. Make sure you are using rosin core solder for this step. If you accidentally use acid core solder, which is designed strictly for plumbing, the acid will actively eat through and destroy your electronic wiring. Your success relies entirely on using the copper wire itself as a thermal bridge to melt and distribute the rosin core solder. Once the solder coats the connection, pull the iron away and hold the wires completely still. If you shift or bump the wires while they are cooling, you will introduce microfractures into the metal. This structural failure is called a cold solder joint. You can verify your work visually. A properly cured, structurally sound joint on the left is perfectly smooth and highly reflective. A compromised cold joint on the right looks dull, matte, and crumbly. You can also use the thumbnail test. Run your nail across the wire like you're strumming a guitar string. A solid joint rings out with a slight musical note, while a bad joint yields a dull thud and needs to be reheated. When you're finished, clean the iron's tip one last time and apply a heavy, fresh coat of solder before turning the power off. Keeping the joint completely still guarantees electrical integrity, while aggressively retinning the tip as it cools protects the iron's surface for your next project. By following these steps, that initial twisted wire is now mechanically locked and electrically permanent. To make this process second nature, build your muscle memory by practicing this exact wire-to-wire connection 10 to 20 times. Mastering your thermal control on thick, robust copper wires is a mandatory prerequisite before you attempt work on delicate printed circuit boards, where too much heat can fry a component instantly. Understanding the fundamental maintenance and thermal physics of your soldering iron provides the foundation for building any electronic circuit.